Hey, welcome back to my lab. Lately, I've been spending some time on getting my lab set up for a 10 megahertz reference standard. This one in particular is the most recently added unit to my lab. What this is, it's a distribution amplifier, model number HP5087A. What it does is it takes a source as an input, it amplifies that signal and then distributes that signal across to its output ports. This one has been set up on channel A to take in a 10 megahertz input source, and then puts out 12 channels as the output. The output from here is currently fed into my 5334B. You've seen this unit in my previous video where I replaced its power and safety caps. It has a built-in oven controlled oscillator, and it does a pretty good job, but we could do better, and I'll cover that later in this video. So this gets the input from the distribution amplifier. So does my RNS, the SME03. Spanning across my lab here, this one is my most recently added Agilent HP8648B. It is also a signal generator. It's got some additional features, and it operates between 9 kilohertz to 2 gigahertz. That also receives the standard reference output from here into it, and so does my HP8594E. This is the spectrum analyzer. Additionally, I had recently purchased another test equipment into my lab, and that is my HP53132A. This is a universal counter. It's a fantastic unit. It's got tons of features, and I'll do a separate video on this. It has a built-in high quality oven controlled oscillator, and it's acting as a source as of now, and it is feeding the distribution amplifier, and it's a fairly good quality oven controlled oscillator. It does a pretty good job. I think it's fairly stable. Even when the power is turned off, the oven continues to be powered up so that it stays nice and warm, and provides the flow of the 10 megahertz signal, if you will. On top of this is my Siglent, the SDG 1032X, the function generator that also gets the output from my distribution amplifier. And last but not least, this is my Advantest, the VNA. It has, by the way, this one has a separate S parameter test set. A very, very nice gear, to be honest. Honestly, I haven't used it enough. So this also gets the input of the 10 megahertz standard from the distribution amplifier. Now, this video is about how can we get even better as it relates to the 10 megahertz reference standard as a source. Yes, this does a pretty good job for acting as a source, and it's fairly stable. I'm very happy with it, but we could do better. So this video is about covering what can we do better. A recently purchased 10 megahertz Rubidium oven controlled oscillator. I bought this on eBay 2 days ago. It just arrived in the mail. I took the label out, but I haven't opened the box yet, so let's do that together, and we can see what's in there together. And I don't know exactly how it looks. Well, I know how it looks from the pictures. I haven't really touched and felt it, so this would be a good joint experience for us. So with that, let me get this started, and we'll get this cracked open and see how it looks, and we'll go from there. Okay, so I'm going to get this opened here, and let's see. All right. Oh boy, we have the peanut packing, and I don't like those. It can get pretty messy. So let me do this. I'm gonna let's see how bad it is. Well, so here's the a note from the seller. By the way, I'll put a link to the seller's name in the description if you guys are interested. Great seller, sounds like a very knowledgeable person in the time and frequency standard subject matter. Seems like he's a nerd in that area, so I'm fairly impressed with his knowledge, etc. So that's that. I'm going to put that aside, and looks like I need to dig through this the peanut material, and let me do that, and I'll be right back. Okay, now let's get to cracking this open. And all right. Okay, so this looks just like how it was in the picture, so that's good. No surprises there. And let me get this Ziploc opened up. Nice. I didn't realize this was kind of light. I mean, I expected this to have some heft to it, but it's lighter than I had expected, so which is fine, not a big deal. So, any case, if you can see here, let me see if I can do a close up. So this is the Phoenix Research Group, Rubidium 10 megahertz reference, and let's see if I can zoom back a little. It's got the, I'm gonna tilt my camera a little. It's got the 10 megahertz output. It's got the unlocked, locked indicator, like an LED here. These B and C connectors are gold plated. The whole unit is pretty well made on the back. That's the power input. That looks like to be for grounding. Outside of that, it's fairly straightforward. There is the oven controlled rubidium oscillator. The oven itself is located here, I believe, and then the output from the oven is fed to the front, and the power supplies, of course, from there. All right, so let me see, and what else is in the box? We also got this power supply, and he did say it's not the greatest of the power supplies, but he thought it was a good quality, so that's good. And I'm gonna hook this up, and for a minute before I hook it up, I'm gonna give a quick tour of this. So that's the rear side, and let me set this up here. So I'm quite impressed with how well this is made. So I'm going to get this placed in the lab and then we'll hook it up to the power supply. I believe it requires a good amount of time for it to kind of warm up and stabilize, and I think it takes, they recommend, I think, what is that, 24 hours to get the things going. But I'll wait till, well, I'll hook it up and we'll do another quick shoot of a short video clip to make sure you guys are able to see that too, and I'll be right back. Okay, so I put this up here, and I think it took roughly 4 minutes according to the spec for it to get it locked in. But I think also I've read that this needs to be running for much longer time for it to kind of stabilize. But I was able to get this locked. Right now you see that unlocked LED is not lit. It means it's locked, and it's putting out, of course, it puts out the signal soon after you plug it in, and then once it's locked, supposedly that's a stabilized signal. And I currently hooked it up to my 5334B, and you can tell it's fluctuating between this and then 10 megahertz, which is pretty good. So I'm quite impressed with that. So I'm going to let this be, let it run. Thanks for watching, and we'll do a follow-up video once this is all stabilized, and I'll then do a video on this 53132A universal counters calibration process using the new Rubidium based 10 megahertz reference standard. Thanks for watching. Have a good day. God bless.